For question 1, explain the meaning of differentiation and techniques of differentiation. So in mathematics, differentiation is the process of finding the derivative of a function which represents the instantaneous rate of change of that function with respect to its input variable. The technique involves using various rules and formulas to calculate the derivative, including the power rule, sum or difference rule, products rule, quotient rule, and chain rule. Now you will see the explanation for all the rules that was written in question 1. This is question 2, presented by Damia.
Hey guys, I will proceed with question 2A and B. And for question A, we will be using product rules because the relationship is multiplication. And I will assign for x to the power of 2 as u and also cos 5x minus 2 as v. And we will differentiate each part. From 4x to the power of 2 differentiate will become 8x and also cos 5x minus 2 differentiate. Remember, cos differentiate will become sine since it is a trigonometric rule. And keep in mind that 5x minus 2 will be remain and not will be changed. This one, it will become this one. And also we need to differentiate the inner part and we will be left with 5. And this is the final answer. And after the differentiation part, we will apply the product rules. This one is u, dv over dx. And this one is v. This one is v and this one is du over dx. And this one is the final answer after combine this one. For question B, we'll be using quotient rule since there is fraction here. So this one is quotient rule. Now we'll assign 3x plus 1 as u and v equal to sine 2x. Differentiate 3x plus 1 will become 3, we'll be left with 3. And also sine 2x will be left with cos. Same with this one, sine differentiate due to trigonometric rules. And sine 2x will be remain and also differentiate. This one will be left with 2 and this is the final answer. And after differentiate all the parts, so we will be apply quotient rule and combine. This one is v, this one is du over dx, and this one is u. And this one is dv over dx combined. So this one is v square. This one. The reason why sine is power of 2 because we are multiplying sine x multiply sine 2x and it will become this one. So that's all for me. Thank you.
Now we'll move on to question 3, presented by Ronny.
Hello everyone, so now we're going to answer question number 3 using implicit differentiation. So the first step is we need to differentiate every term. So we write this, we copy it from the question above. And then for the first term, we're using product rules. So for you guys' information, the product rule formula is this. So let's start here. So we let u equal to y and then the differentiation, it will become dy dx. And then after that, we let v equal to ln 2x. And by the way, for you guys' information, in logarithm rules, it is 1 over x, but it will become 1 over 2x because we got 2x here. And then before that, we need to know which is the outer and inner part. So ln is the outer part and the inner part is the 2x. And then we got here, and we got the answer 2 over 2x, we dividing off, and it become 1 over x. So after that, we from the formula that we given, we use it and we rearrange it and we got the answer. The final answer is this. Okay, so The next term, we are also using chain rules. And then for you guys' information, in logarithm rules, the exponent will become exponent. It doesn't change anything. Before we differentiate, we need to know which is the inner and the outer part. So the inner part is the 5x plus 3, and the outer part is the exponent. And after differentiate, we differentiate the outer part and the inner part, and then finally we get the answer here. And then for the third one, we're also using chain rules to differentiate it. So trigonometry rules, tan it will become sec square. And now we need to know which is the outer and the inner part. So the outer part is the tan, and the inner part is the 6y. And after we differentiate it, we got the second square 6y times 6. For the outer part is this, and for the inner part is this. And then after that, we got the answer. The final answer is this. Don't forget about the dy dx. Now, the final part, the implicit differentiation. The first step, we need to copy all the differentiation that we already do for our term. We rearrange it like the question above. So after that, the second part is we need to rearrange all the dy dx to the left-hand side and the normal one to the right-hand side, like this. And then for the third part is, we need to make a bracket so that we need to factorize it, so that we need to bring it, the left-hand side factorize, we need to divide it with the normal equation. So it will become this, the final answer. That's all for me.
Now we're on the final question, which is presented by me, Aina. Hi, so I'm going to be solving question 4 using linear approximation. So first of all, this is the formula for linear approximation, where first we need to know the value of x null, delta x, and f prime x null. So for the first step, as we both know from this equation, they have the same value. So we need to change it to x. As you can see, this is the radical form, and we need to change it to index form. So using this formula, we can change it to index form, and then we need to differentiate it. So it will become this equation. So for step 2, we need to know what is the x. So the x is the original value, which is 63.98. And this is the x null. So the x null is the value to estimate from, which is the value closest to 63.98, which is 64. So this is the formula we need to use to find delta x. Delta x is the small changes of x. So after apply to the formula, we will get the answer for delta x is negative 0.02. So for step 3, based on the function of x, we change the x into x null. Then we need to substitute the x null into 64 because the x null is 64 here. And after calculating it, it will become 15/4. And the same with f prime x null. We use this equation where we substitute the x into 64, it will become 35/1536. So for step 4, the last step, we need to apply all the information we got from step 2 and 3 into the formula. So x null plus delta x is actually x. So we already know the value of these both terms, which is 15/4 f x null, and 35/1536 is the f prime x null, this one. And the delta x is negative 0.02, where we can get from step 2. Then the x, we actually already know, which is 63.98 from step 2. And we just apply it to this formula. Then after calculating this equation, we will get 3.7495. To conclude, 63.98 cube root minus 2/63.98 cube root is approximately 3.750. So we need to round off this into 3 decimal places because the question wants 3 decimal places. So this is the final answer. So that is all from me. Bye-bye.
Now, in conclusion, technique of differentiation are foundational tools used to determine the rate of change of function. This technique allows us to find derivatives efficiently and apply them to real-world problems. Mastering this technique helps in analyzing curves, finding tangent line, solving optimization problems, and understanding motion. Together, they form a powerful toolkit that deepens our understanding of how functions behave and change.